This is my beginning algebra course. Today we're going to learn how to solve equations with squares. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. So as you can see, we have an equation with a variable that's squared. And this equation is asking us to find x. X is a number, but we don't know what the number is. So we have to figure out what number x is. Now, the first step when you have equations with squares is to isolate the square. In this equation, the square is already isolated. In other words, x squared is by itself on one side of the equation. So we have that done for us already. So now we just have to get rid of the square. We want x. Right now we don't have x. We have x squared. We know x squared is 36. We don't want x squared. We just want x, so we have to get rid of this square. So we're going to rewrite the equation, and to get rid of that square, we're going to do the opposite of squaring. Now we learned in the last class that the opposite of squaring is square rooting. So we're going to square root both sides of the equation to get rid of that 2 power. And don't worry about the plus or minus right now. I'll explain that later. So remember, whenever we do something to one side, we have to do it to the other side in order for the equation to remain true. And again, remember, if you have an equation like x plus 2 is equal to 7, and you want to isolate x, get it by itself, you do the opposite of adding 2 because you want to get rid of this 2, so you subtract 2. So again, we're square rooting because square rooting is the opposite of squaring. So it's really just the same logic. So this gets rid of the square, and you're left with x. And then we just have to find the square root of 36. What number times itself is equal to 36? Well, obviously that's just 6. And that's our answer. So now I want to explain where that plus or minus comes from. Now this is going to be a little weird. We learned that when you're asked to find the square root of a number, for example, if you're asked to find the square root of 9, the answer is always going to be positive, because this notation assumes that the answer is always going to be positive. That's just traditionally what this notation means. It's not asking you to find a negative number. So, but we also talked about, we discussed why this is sometimes asking, students are kind of confused. They want to know, well, if you're asking what number times itself is equal to 3, then negative 3 should be an answer as well. So it's confusing because why is it only positive? Well, again, it's just tradition that this notation is only referring to a positive number. But the confusing thing is that when you have an equation, like the equation we have here, you're looking for any number that will make this equation work. So if you square 6, you get 36, but if you square negative 6, you'll get 36 too. So negative 6 and positive 6 are both answers. And I know that that's very confusing because when you square root a number, it's always positive, but when you have an equation where you have to square root both sides, you always have 2 answers, a negative and a positive. So it's very confusing. Students don't understand why you get 2 solutions when you have an equation, and you only get 1 solution when you just try to simplify this notation. Again, I know that's confusing. It is confusing, but that's just the way it is when it comes to this math. So you're going to have to get used to it. So when you're solving an equation, you're going to get 2 answers. You're going to get a positive 6 or a negative 6. And by the way, don't be confused by this plus or minus sign. I think we've seen that a few times, but that just means that x can be 6 or x can be negative 6. So that's all that means. But we don't want to write 2 equations, so we just write plus or minus. So let's try one more of these before you try one on your own. We want to isolate the square. Now in the previous problem, the square was already isolated, but in this problem it's not because we have a 2 there. We got to get rid of that 2. So we're going to rewrite the equation and we're going to get rid of this 2. Now remember, Fraction sign means division, so that's y squared divided by 2. So we have to do the opposite of division, which is multiplication, and we show multiplication with parentheses, and then we get 16 is equal to y squared. So it looks like I'm going to need some more room here. Actually, I think I'm just going to make this writing smaller. So now we isolated the square. That's the first step, is to isolate the square. So now the square, y squared, is by itself. So now we just have to get rid of that 2, because again, we're not looking for y squared. We don't want y squared. We want y. So we have to get rid of that second power. So we rewrite the equation, and we square root both sides, and I got to put my plus or minus. And the plus or minus always goes on the opposite side of the variable. You could actually put it on either side, but we're not gonna do it that way. We're just gonna put it over here. That's the traditional way to do it. And I'm gonna go ahead and try to move this down a little bit. So then our answer is going to be this square root gets rid of the square, so now we have y is equal to plus or minus, and what number times itself is equal to 16? Well, that's obviously 4. And if you're having trouble with this square root stuff, that might mean that you didn't do the homework from the last class, so that's your fault. You need to go back and do that homework. So plus or minus 4 works. So if you plug in 4, you get 16 divided by 2 is 8, so it works. If you plug in negative 4, you get negative 4 times negative 4 is 16, divided by 2 is 8. So both of those answers work. All right, so now it's time for you to try. The first step is to isolate the variable, but we don't, or isolate the square, excuse me, but we don't need to do that here because it's already isolated. So you just have to square root both sides to get your answer, and be sure to write your plus or minus. So go ahead and try number 3, and when you come back, we'll do it together. All right, we're back. So you rewrite the equation and square root both sides. And I didn't mention, I want you to rewrite that equation. I want you to show what's going on here. And be sure to write your plus or minus. And again, the reason we're rewriting the equation is because we need to show what we're doing. I want you to get used to this notation. So if you just square root the original equation, well, guess what? Now we don't know what the original equation was. We can't go back and study this problem to help you prepare for your test because the original problem is all messed up. And so we have to preserve the original problem, so that's why you have to rewrite it down here. So now we get x is equal to plus or minus 9, because 9 times 9 is 81. So if you got plus or minus 9, good job. So again, this works because if you plug 9 back into the equation, 9 times 9 is equal to 81. It works. And negative 9 times negative 9 is 81, so it works. So if you got plus or minus 9, good job. Try number 4. When you come back, we'll do it together. All right, we're back. So I want you to rewrite the equation. Get rid of that 5 because we're going to isolate the square. That's the first step, is to isolate the square. So we have y squared is equal to 25. And then I want you to rewrite again. And we need to get rid of that square root. Or excuse me, we need to get rid of the square. So we do the opposite of squaring, which is square rooting. That gets rid of this square, and so we're left with y is equal to whatever the square root of 25 is, and that's obviously 5. So if you got plus or minus 5, good job. Again, there's 2 answers to pretty much every one of these problems. There's always 2 answers to these. All right, so let's do number 5 together. It's pretty much the same thing. We want to isolate the square. That's what we have to do. That's the first step in these problems, and all these problems in the class today. That's the first step, is to isolate the square. And you know what? I'm not going to rewrite. Well, I guess I will. And I should use different colors. I'm going to start using different colors here. So then we get z squared is equal to 1. So I isolated the square because I got rid of the 6, and now the square is by itself on one side of the equation. So now I have to get rid of that square. So we square root both sides, and we end up with z is equal to plus or minus 1, because the square root of 1 is 1. it's asking what number times itself is equal to 1. Well, that would just be 1, because 1 times 1 is 1. All right, so why don't you try number 6? Number 6 is going to be just like the problem we did, and when you come back, we'll do it together. All right, we're back. So I guess we're going to rewrite the equation. I'm not going to require you to rewrite every time, because it's going to get pretty tedious if we have to do that every single time. When we get to the more difficult problems, I'm going to put a divider here. So we're going to subtract 7 from both sides to isolate that square. And we get this equation. And then I'm going to rewrite, because I'm going to square root both sides. And something interesting happened with this problem. I probably should have warned you about that. We can't do anything with square root 2. 2 is not a perfect square. Perfect squares are 1, 4, 9, 16, 25, 36. 2 is not one of those perfect square numbers. So that means that we just have to leave it as square root 2. So I'm sorry I didn't warn you about that. But those are the answers. Positive square root 2 and negative square root 2. Those are the answers. All right, so let's see here. Let's try number 7 together. So I'm going to rewrite the equation. And I'm going to isolate the square. That's the first step. Isolate the square. And I get y squared is equal to 4 over 3. So now I've isolated the square. The second step is to get rid of the square. So we're going to rewrite. And the opposite of squaring is square rooting, so we're going to square root both sides of the equation. And please don't be messy. If a y squared is too close to the equal sign, don't just put a square like this and run it into the equal sign. Be neat. Erase the y squared and move it over if you have to. It's easier for me because I've got a digital notebook, but you still need to be legible. So now we've got y is equal to square root 4 over 3. Now, we learned in the last class how to deal with these square roots. So that just becomes square root 4 over square root 3. And that then simplifies to 2 over square root 3 is equal to y. And then we have to rationalize the denominator. So we multiply both sides by root 3, and we get 2 root 3 over 3. So I'm not going to explain all of that, because if you did the homework from the last class, you should be able to figure that out on your own. So I know what you're thinking. You're thinking, that's not fair. You needed to show me how to do this. Well, I really don't need to show you how to do it, because again, if you did the homework, you know how I got from here to here. And if we show every single step, this class is just going to be a 3-hour-long class, and I don't think you want that. So again, if you forgot how to go from here to here, then you need to go back to the problems in the previous class. All right, so that looks correct. Let's go on to the next one. So let's see if you can try number 8. And again, I skipped a lot of steps here, but this is just something that you need to learn how to do quickly. I don't require that you show all these steps. I just require that you get the answer. But I do require that you show these intermediate steps. So try number 8, and when you come back, we'll do it together. All right, we're back. So we're going to rewrite the equation. We're going to isolate the square. That's always the first step. And after we isolate the square, the second step is going to be to get rid of the square. So we're going to have to rewrite. And the opposite of squaring is square rooting. So we got rid of the square, and we got plus or minus. And now we have to simplify this root. And looks like that's going to be square root 5 over 2. And again, if you forgot how I went from here to here, just look to the previous class. We don't have time to show every single step when it comes to going from here to here. It's just going to make this course 3 hours long. All right, so if you got that answer, good job. All right, so now we're going on to a problem that requires 2 steps to isolate the square. So if I show every single step when it comes to isolating the square like I did in the previous problems, this is going to start to take a long time. And this is a perfect example of a stage in this course where you need to start skipping steps. So if you took my last course, pre-algebra, you know how to isolate something in an equation. You don't need to show every single step. We don't need to show adding 7 to both sides. We don't need to show dividing both sides by 8. We don't need to show all that because I know that you know that notation from previous classes in this course, but also primarily my previous course, pre-algebra. So I'm not going to show every step because, again, if I showed every step, I would use all of this space plus more. It would just keep going on and on and on. And we're going to do even more complicated problems, so it's going to get tedious if we have to show every step. So I'm not going to show every step. I'm just going to isolate. I'm going to do 2 steps at once. I'm going to add 7 to both sides, and that would give me 32. And this would disappear, and then I'm going to divide both sides by 8. And that would make this disappear, and on the other side, 32 divided by 8 would be 4, and there you go. I did 2 steps in my head. Now, if you didn't take my previous course, if you didn't do the homework in my previous course, if you didn't take a serious pre-algebra course, then this is very frightening to you. All I can say is just go back and take a serious pre-algebra course. I can guarantee that my pre-algebra course is a serious course. Go back and review those problems, and the fear will go away. You should be able to do 2 steps in your head because, again, at this point, we can't show every single step. It's just going to take too long. So I did 2 steps in my head, and I didn't show the steps. I just showed the result after performing those steps. But again, this is just basic stuff. If you took my pre-algebra course, that's really easy stuff for you. So now we're going to get rid of the square. So I want you to rewrite, and as usual, I wrote the 4 too close to the equation. I'm going to move that over. So we get rid of the square by square rooting, and we have plus or minus 2. So that means 2 works in this equation, and negative 2 works. So if you plug in positive 2, we get 2 squared is 4. 4 times 8 is 32. 32 minus 7 is 25. That works. If you plug in negative 2 times negative 2 is 4. 4 times 8 is 32. 32 minus 7 is 25. So that works also. These are solutions because they work when you plug them back into the equation. You get 25 is equal to 25, which means the equation works. If you got 26 is equal to 25, you know you did something wrong. So now it's time for you to try. So again, I don't require you to show the 2 steps. I only require you to show the result after performing the 2 steps. And I know that might seem a little intimidating, but you need to get used to this now because we're going to be doing problems that are very, very complicated in this course, and you cannot show every step because you'd have about 20 steps that you'd have to write. It would take the entire page plus another page just to show it. So we're getting to the point in this course where we're going to start to skip steps, and you shouldn't be worried about that. It shouldn't cause you nervousness or anxiety because if you took my pre-algebra course, you should know how to do these basic operations. So try number 10, and when you come back, we'll do it together. All right, we're back. So I'm going to add 3 to both sides, and I get 7. And I'm going to divide both sides by 8, and I get 7/8. Again, if you add 3 to both sides, this disappears, and you get 7 over here because 4 plus 3 is 7. And then after you do that, you have 8y squared is equal to 7, and then you have to divide both sides by 8, and you get 7/8. I'm doing that all in my head, and you have to do it in your head also, unless you want to show all those steps. And if you want to show the steps, I'll see you next month because you're going to be doing this for a long time. All right, so now we have to rewrite, and we have to get rid of that square. That's the second step, is to get rid of the square, and the opposite of squaring is square rooting. So we square root both sides of the equation, and we end up with plus or minus root 7. Let's see here. I'm going to have to do a lot of that, so we can't. This needs to be simplified, so it's going to be. Let's see here. Plus or minus root 7 over 2 root 2. So again, if you don't know how I got there, just go to the previous class. I'm skipping steps when simplifying the root. The problem is we have a root in the denominator, and we have to rationalize the denominator. So then I'm going to multiply both sides by square root 2, and I get square root 14 over 4, because this becomes 2. When you multiply both sides by square root 2, that just gets rid of the square root 2, and then it becomes 2 times 2 is 4. Anyway, I don't need to explain this because, again, we went over this in the last class. The difference is I'm skipping all the steps. I'm not showing all of it. All right, so if you got plus or minus square root 14 over 4, good job. I realize I sprung that problem on you. We should have probably done that one together. But if you got stuck on that last step, or if you stopped here, just know that you can't stop there because we have to rationalize the denominator. All right, so let's try. I'm going to try to predict those problems. I don't want to give you another hard one. But problem 11, we'll do that one together. We're going to isolate the square as usual. So to isolate the square, and this is the square, we're going to get rid of this 6. So we're going to subtract 6 from both sides. And we get 2, because the 6 disappears, and 8 minus 6 is 2. And so now we've isolated the square. Now, it's important to understand that we want to get to the a. We want to isolate a, but we can't get to the a unless we get rid of this 2 first. So, as usual, the second step is we're going to get rid of the square. And so in order to do that, we're going to have to square root both sides of the equation. So again, it's the same procedure. You isolate the square, and then you square root both sides. And of course, I'm going to rewrite the equation. To preserve the result of my initial step. And then we have a plus 3 is equal to plus or minus square root 2. And we can't really do anything with square root 2, so we just leave it as square root 2. And so now the square is gone, so we can get to the a. We want to isolate a. So we're going to subtract 3 from both sides. And that's our answer. Now please understand that I could write this as a equals plus or minus root 2 minus 3 also. It's just a different order. I could put the negative 3 on the left, or I could put it on the right. It doesn't really matter. So just be aware of that. In fact, I'm going to go ahead and try to preserve that. I want to show you that you can do either equation. And maybe I'll color that a real bright color so you can go back and see that that's an important point. And I'm going to put a star by this problem because, again, I want to demonstrate that you can put the number on the left or on the right when you're dealing with sums and differences of square roots. So that is the answer. All right, so let's go on to number 12, and why don't you go ahead and try number 12. Again, you want to isolate the square, and then square root both sides, And I do want you to rewrite when you square root both sides to preserve the result of the first step. And so go ahead and try number 12, and when you come back, we'll do it together. All right, we're back. So we're going to add 1 to both sides, and we get 7. And that is the first step. We isolated the square. The square is now by itself on one side of the equation. So now we rewrite, and we square root both sides. And remember, you have to put your plus or minus on the step where you square root both sides. That's probably the most common mistake, is students either forget to write the plus or minus, or they write it in the next step, but they don't write it when you actually square root both sides of the equation. If you don't write a plus or minus when you square root both sides of the equation, then the equation is actually going to be wrong. You never want to write an equation that is technically wrong. A lot of students don't know, well, should I put it on this side or should I put it on this side? It's always going to be on the side opposite of the variable. To be honest, you can put it on both sides, but I want you to put it on the side opposite the variable. So the variable's over here, I want you to put it on the opposite side. So we can't really do anything with square root 7, so we just leave it. We could enter it into the calculator, but that would just give us a decimal that would go on forever and ever and ever. I don't know what it would be. It would probably be something like 0. It'd probably be like 2.47. Just keep going on and on and on. So we can't write that, so we just have to keep it as a root 7. Then we subtract 5 from both sides, and you can put the negative 5 here, or you can put it on the other side. On this problem here, I wrote the number on the left side of the root, so I'm going to write it on the right side of the root just to show you can do it either way. So if you got that answer, let me move that up a little bit. Sorry. If you got that answer, good job. So let's go on to number 13. So this is going to be a fairly easy problem. We'll do this one together. So we're going to rewrite the square. The square is already isolated, so we don't really need to isolate the square. And so the next step after you isolate the square is to square root both sides as usual. Sorry, I'm going to move that over a little bit. And the situation here is we have a perfect square inside the root as a factor. So if you recall, we just factor 20 to 4 times 5. We could factor it to 2 times 10, but neither 2 nor 10 are perfect squares. And we could factor it to, actually that's the only factorizations for 20 is 4 times 5 and 2 times 10. So 4 times 5 is going to work because 4 is a perfect square, so we take 4 out. And it becomes a 2 because when you square root 4 you get 2, and the 5 stays inside. So that is the answer for number 13. Now if you're struggling with this and you don't know how I went from here to here, then you need to go back to the previous class. You may not have done the homework, or it may be a while since you did the homework. Notice that I didn't show the steps. In the previous class I showed all the steps from root 20 to root 5. I'm not going to do that anymore. And the reason I'm not going to do it is because it would take too much room. It would take the entire page to show every single step if we're going to show all the steps for each one of these problems. So just go back to the previous class and make sure that you know how to get from here to here. So try number 14, and when you come back, we'll do it together. All right, we're back. So we're going to rewrite, square root both sides. And 88 is 4 times 22, I believe. I showed a step right there, unlike the previous problem. You could use your calculator to figure out that 88 is 4 times 22. You just divide 88 by 2, and you get 2 times 44. You divide it by 4, you get 4 times 22, and bingo, you have your 4. So you can just try a lot of different things. You could try 8 times 11, but neither 8 nor 11 are perfect squares. So you just got to try different factorizations. And now, because we have a perfect square, the 4, we can pull it out. And our final answer is, and that's too scrunched up there, our final answer is 2 root 22. So if you got that answer, good job. All right, so now we're going to go to some a more difficult problem. We'll do this one together. Now I want you to be very aware at this point that I'm going to start performing multiple operations at the same time. So we need to isolate the square, but we need to get rid of the 9 and the 2. Now if I tried to show subtracting 2 and multiplying by 9 and all the different steps, like I said, it would just take forever to finish this class. It would take 3 hours. I don't need to show you how to subtract 2 from both sides of an equation. I don't need to show you how to multiply both sides of an equation by 9. If you took my previous course, my pre-algebra course, you should already know how to do that. So I'm not going to rewrite and then write minus 2 and minus 2 on both sides. Again, this is all baby stuff that you should have learned in a previous course. If you're rusty on that, you can go back to my pre-algebra course. But again, we don't have the time or the energy or the space on the paper to write every single step. It would just it would be 10, 15, 20 steps. So what we're going to do is we're going to isolate the square, and we're going to do 2 steps in our head to do that. So we're going to subtract 2 from both sides, and I'll get rid of the 2, and this will become a 5. And then we're going to multiply both sides by 9 to get rid of this, and 5 times 9 is 45. There you go. So I did 2 steps in my head. Again, the reason we're doing this is you're starting to get to math that is complicated enough to where you need to start skipping some steps. You can't show every step, or else you'd be here all day doing one problem. And you're at a level where teachers are going to trust that you know how to do those type of things already, because you learn that in previous courses. So you don't need to prove to the teacher that you can do that, or that you can show how to write that is. So again, the 9 is the x plus 3 squared is divided by 9, so that's why we multiplied. So subtract 2, you get 5. Multiply by 9, 9 times 5 is 45. So hopefully you see that. So now we have to rewrite, because we're going to square root both sides. Remember to put your plus or minus. And we're going to pull out a perfect square here. 45 is 9 times 5. 9 is a perfect square, so 9 comes out as a 3. And then all we have to do is just subtract the 3 to isolate x. Again, we're trying to isolate x. That's the point of all these equations. That's the point of every algebraic equation pretty much, is to isolate the variable. So we can put the negative 3 here, or we can put it here. I'm going to put it on the left this time, because we're subtracting 3, so it would be negative 3. And that is the answer. So on to the next problem. So why don't you try number 16, and when you come back, we'll do it together. All right, we're back. So I'm going to isolate the square in one step without showing the steps. I'm just going to write the result. And we get add 8 to both sides and multiply by 12, and you get 84, it looks like. That's kind of a big number. I'm sorry you got such a big number there. So we isolated the square. We did 2 steps in our head at once. So now we have to get rid of the square. So we do the opposite of squaring, which is square rooting, and that gets rid of this 2 power. That's the point, is to get rid of that 2 power. And we don't have to write the parentheses here anymore. because we're not squaring it. If you're squaring it, you need parentheses, but if we're not squaring it anymore, we obviously don't need parentheses. So there's going to be a perfect square here, but we need to think about this. What we need to factor 84. So I need to pull out a perfect square, and I just know it's going to be 4 times 21. But if you didn't know that, just get your calculator and divide 84 by 2, and you get 2 times 42. And try dividing it by 4, and you get 4 times 21, and bingo, we can see that we have a number that doesn't have a perfect square as a factor, and a number that is a perfect square. So 4 comes out as a 2, and the 21 stays in. Remember, whenever you have a perfect square factor, whenever you have a perfect square factor, the perfect square comes out, and you square root it. Again, we learned all this in the previous class. Don't complain and say you're going over stuff that we haven't done, because I am not going over stuff that we haven't done. You did this in the previous class, or if not the previous class, and then a class before that. Sometimes I order the classes differently, depending on how I decide to put them together at the end of the course. But you've already done this. This is just review. But I'm not showing the steps of pulling out the perfect square. I'm just if we tried to show those steps, it would just take forever to finish these problems. All right, so I'm just double checking that. So if you got that answer, good job. All right, let's do number 17 together. This really troubles students. This really makes students upset. They don't know what that 2 is doing there. You might try to distribute that 2 into the parentheses. Don't do any of that. What you want to do is isolate the... in fact, you know what? I'm going to show the steps on this one, because I feel I just experience has shown me that students really get confused by that 2 in front of there. So I added 4 to both sides, and I showed the result after adding 4 to both sides. That was the first step. Now I'm going to divide both sides by 2. So again, this is 2 times all of this. So in order to get rid of the 2, I have to divide by 2. So I divided both sides by 2, and I got rid of this 2 here, and 6 divided by 2 is 3. So this just means you're multiplying into the square expression. So to get rid of that 2 and isolate the square, because the square is now isolated, it's by itself, we have to divide by 2. So again, this is really troubling to students when they see this 2 next to the parentheses. That really makes them uneasy. It's a source of confusion, but hopefully you understand now what it actually means. Again, when you have something next to parentheses, that means you're multiplying that number into whatever's inside the parentheses. In this case, you're multiplying by the entire square. Because remember, order of operations tells us to raise to the second power first, then multiply. So you can't just put the 2 inside here. Don't try that. That's one of the sources of confusion. So now we just square root both sides because we've isolated the square. And we get y minus 5 is equal to plus or minus root 3. And we can't do anything with root 3 because there's no perfect square in there. So then we just add 5 to both sides. And again, I can put the 5 over here on the right, or I can put it on the left. It doesn't really matter. If you put it on the left, you don't need a positive sign in front of the 5. If you put it on the right, you do need a positive sign to connect it to the root 3, or else it looks like multiplication. If you just put a 5 randomly, if you put a 5 randomly here, it just looks like root 35 or something. All right. So again, I know this is a lot to take in, but you're just going to have to get practice, and that's the only way really to learn this language, is to do practice. So I'm trying to keep my equal signs lined up, but as you can see, it's not always possible when you have limited room here. All right, so you try number 18, and when you come back, we'll do it together. All right, we're back. So we're going to do 2 steps at once. We're going to subtract 2 from both sides, and this 2 will disappear, and we'll get negative 18 here. and then we'll divide both sides by -3. -18 divided by -3 is 6. So I did 2 steps in my head, and I isolated the square. All right, so now I'm going to square root both sides. Y minus 5 is equal to plus or minus root 6. And then we're going to add 5 to both sides. And there you go. So if you got that answer, good job. On to number 19. We'll do this one together. Let's see here. Now this problem is going to be a lot easier if we just kind of cheat and we move this negative down here. That's going to make it a lot easier to understand what's going on. So I'm just going to move it down there. And now you can see that in order to isolate the square, I have to subtract 11 from both sides, and that's going to give us a -4 over here. And then I'm going to multiply both sides by -2, because this is divided by -2. To get rid of -2, I have to do the opposite, which is multiply by -2. So I have -4 over here. I multiply both sides by -2, and I get +8. Again, don't complain that I'm not showing those steps. That's baby algebra. You learned that in the last course. So I subtracted 11 from both sides, and then I multiplied both sides by -2, and I got +8. I did 2 steps in my head. So now we're going to get rid of the square, and this is just all stuff that we've done 5 times already, or 10 times already today, 18 times, that is. So now we have an issue because we have a perfect square factor. How do I know that? Well, because I know 4 times 8, or 4 times 2 is 8, and 4 is a perfect square. So I have to pull out the 4 as a 2. And again, when you pull out the 4, it becomes 2 because you're square rooting the 4. And the final answer is -3 plus or minus 2 root 2. Again, I could put the -3 over here if I wanted to, but I decided to put it on the left side. All right. So time for you to try one of those problems. This problem is going to be easier because there's no negative here, so we didn't have to do that little trick there and put it down here. Try number 20, and when you come back, we'll do it together. All right, we're back, so we're going to isolate the square. That's always the first step by doing 2 steps in our head. So we're going to subtract 12 from both sides, and that gives us 9. And we're going to multiply both sides by 2, which gives us 18. Then we're going to square root both sides, but we have to rewrite before we square root both sides. And it's really common for students to forget to put that plus or minus. They think, well, I don't really need to put that. I can just leave that out. Well, you really cannot leave that out because you're going to get the wrong answer. There's 2 solutions, and you have to find both of those solutions. In fact, I would say when it comes to this class, that's the #1 mistake that students make, is they do not put that plus or minus. Not only do they not put that plus or minus, but well, sometimes they do put the plus or minus in the final answer, but they don't put it here when they square root both sides. I probably should have mentioned that or warned people more clearly. You have to put the plus or minus in the step where you square root both sides, or else the equation technically is not true. All right, so we're going to pull out a perfect square. I know 18 is 9 times 2, and that's why I know I can pull out a perfect square. I pulled out 9 as a 3. And then z is equal to 5 plus or minus 3 root 2. But I'm just going to put the 5 on the other side just to show you that you can do it the other way also. You can put it over here also. You can put the 5 on the right of the square root or the left. Both answers are correct. All right, that looks correct, so let's do 21 together. I'm going to isolate the square. Again, that's the first step with these problems, is to isolate the square. I don't mean to sound like a broken record, but I just want you to be absolutely sure about how to solve these problems. The first step is to isolate the square. So we're going to add 3 to both sides. That gives us 8 over here. And we're going to divide both sides by 4 because this is 4 times the square, so we have to do divided by 4. And that gives us 2. Then we're going to square root both sides. To get rid of the square. Because we want to get to the x. We can't get to the x unless we get rid of that square first. I should have mentioned that more clearly. We need to get rid of that square first before we can get to this x inside. If you try to do it another way, trust me, it's not going to work. All right, so now we're going to add 10 to both sides to get rid of this negative 10. Adding 10 is the opposite of adding negative 10. That really angers students. They don't like that idea that adding a negative is the same thing as it's the opposite of adding a positive. But that's our answer for that one. Again, you could put plus 10 on the right, or you can put on the left. Either way works. All right, I'm going to put a little divider here just to be sure that we don't run into that problem. I guess we don't really need to. It's far away enough. All right, so why don't you try number 22. When you come back, we'll do it together. All right, we're back. So the first step, obviously, is to isolate the square. And we get x minus 3 squared is 4. We added 6 to both sides to get 16 and divided by 4, and 16 divided by 4 is 4. So now we square root both sides of the equation. And as usual, I'm going to have to move that over to put my plus or minus sign. And we get x minus 3 is equal to, the square root of 4 is 2. So it's just going to be 2. So then the answer is x minus, x is equal to plus or minus 2 plus 3. Now, this is a problem that we probably should have done together, because if you got this answer, this is correct. It's completely correct. But we have to keep going here. I'm sorry to spring this on you. I'm sorry to make you do this problem before we did it together. But again, there's so many variations of these problems, it's hard to predict every single variation. But the reason that we can keep going with this problem is because 2 can actually be combined with the 3. You don't want to leave the answers like this. You can simplify. So let me explain what I mean by that. We're going to break this into 2 parts. And we're going to find the 2 answers. So let's assume that 2 is positive. Again, it can be plus or minus 2. So let's assume that it's positive 2. If this is positive 2, then you add 3 and you get positive 5. That's one of the answers. X equals positive 5. Now, if this is negative 2, because again, it can be plus or minus 2, if it's negative 2, then you add negative 2 to 3 and you get positive 1. So that's the other solution. So, in that problem, we actually had to go one more step. Now again, if you left it like this, it's not wrong. It's just, why would you leave it like that when you can actually find the 2 answers? The reason we didn't do that in previous problems is because we had some sort of a square root and we can't combine it with the other number. So if you got this answer, you did it perfectly. We just needed to go one more step. All right, so let's try number 23 together. Isolate the square, and we get 11 over 3 is equal to y squared. Actually, not 11 over 3, it's 11 over 16. Again, we added 3 to both sides, then we divided both sides by 16. And now we have to square root both sides. And again, we learn how to simplify this. We cannot have a square root in the denominator. So we learned how to simplify that in the previous class. So it ends up being root 11 over 4. Because the square root of a fraction is the square root of the numerator over the square root of the denominator, and the square root of the denominator is a perfect square, so that just ends up being 4. Again, don't accuse me of skipping steps and confusing you. I'm not skipping steps. I already showed you how to do this. I showed you how to do this in the previous class. So you should know how to do that. So if you don't know how to go from here to here, don't get mad at me. This is something that you need to learn in the previous class. If you did the homework, you should know how to do that. If you didn't do the homework, that's your fault and nobody else's. All right. So now you try number 24, and when you come back, we'll do it together. All right, so we're going to do 2 steps in our head, and we get 5 over 9. And then we're going to square root both sides as usual. And by the way, make sure that your square roots go over the entire fraction. A lot of students, they'll do a square root and they'll do something like this. That's not correct. It needs to go all the way down, or else it's going to look like you're only square rooting the numerator, and that would be incorrect. So make sure that goes all the way down. And we get y is equal to plus or minus square root 5 over 3. So if you got that answer, good job. All right, on to number 25. Let's do this one together. Add 6 to both sides and divide by 6. So again, you're going to add 6 first. Then you're going to divide by 6, and you get 1/6. 1/6. So we isolated the square. Now we're ready to get rid of the square. Get rid of the power. So we square root both sides. And now we have z minus 1 is equal to plus or minus. I guess I have enough room here to go ahead and show you these steps. So that would end up being square root 1 over square root 6, when it ends up being 1 over square root 6. Then I have to rationalize the denominator by multiplying both sides by square root 6, and I get square root 6 over 6. And then I have to add 1. So I showed a few steps there when it came to rationalizing the denominator, but I didn't show every step because, again, you've already done all that in the previous class, or one of my previous classes, where we learned how to simplify expressions with square roots. All right, so try number 26, and when you come back, we'll do it together. All right, we're back. Isolate the square. And you're done with the first step. We did 2 steps. Whoops, that's not correct. That should be 5 over 3. There you go. All right, so we did 2 steps in our head to isolate the square. Then we're going to square root both sides. And I keep writing that square too close to the fraction, as you can see. get rid of the square. X plus 8 is equal to plus or minus. I'm going to show some steps here just in case you are becoming angry at me for not showing how to rationalize that denominator. Multiply both sides by root 3 and you get root 15 over 3. And then we just subtract 8 from both sides and you're done. Again, the 8 can go on the left or the right of root 15 over 3. I'm going to have to move that down a little bit. So if you got that answer, good job. All right, so let's try 27 together. So we isolated the square by adding 22 to both sides and dividing by 3. And now we're going to get rid of the square by square rooting both sides. And make sure that square root goes all the way down over the 3 also. And again, we learned in the previous class that this expression would end up being plus or minus 5 over root 3. But then we have to rationalize the denominator. We can't have a root in the denominator, so we change that to 5 root 3 over 3 by multiplying both sides by root 3. Again, you don't have to show every step because it would just take forever. That's something that you needed to learn in the previous class, or one of my previous classes. So we got our answer there. And as you can see, I'm trying to keep the equal sign lined up, but you don't really have to, but it just makes it easier to read. So try number 28. When you come back, we'll do it together. All right, we're back. And there you go. We isolated the square. So now we rewrite, and we're going to square root both sides. And you can't just leave it as square root 6 over 7, so we have to break it up into 2 roots, as we showed in the previous class. Multiply both sides by square root 7 and you get square root 42. Whoops. Square root 42 over 7. Then we have to add 1 to both sides. And there you go. Let me just double check that. Everything looks right. So if you got that answer, good job. Again, if you're having trouble going from here to here, just look to the previous class. All right, on to number 29. Looks like we have 40 problems total. Let's do this one together. 12 over 5. And we're going to square root both sides. And we get y minus 1 is equal to we have to simplify that, so we have to pull out a perfect square in the numerator. So it becomes 2 root 3 over 2 root 3 over root 5. And we're going to multiply both sides by root 5 to rationalize the denominator. So we get 2 root 15 over 5. And you don't really have to show this step. You can just go right to the answer, but I'm just showing an intermediate step. Whoops, I forgot my plus or minus. Can't do that. 2 root 15 over 5 and plus 1. So there you go. Everything looks right. All right, try number 30. When you come back, we'll do it together. All right, we're back. Isolate the square. Square root both sides. Be sure to write your plus or minus. And we have z minus 12 is equal to plus or minus. And now we have to pull out a perfect square in the denominator. Here we had a perfect square factor in the numerator, but here we have a perfect square factor in the denominator. So this becomes 9 times 2, and pull out the 9 as a 3. Again, I'm skipping steps here. I'm skipping steps when I'm simplifying and rationalizing the denominator. But again, that shouldn't worry you, because if you did the homework from the last class, you should know how I'm doing that, and you should know how to do it yourself. You cannot leave the answer as root 5 over 18. And now we just add 12 to both sides. You know what, I've written it like that quite a bit, so I'm just going to put it on the other side just to show you that it can be written on the other side. The 12 can be written on the other side also. So there you go. If you got that answer, good job. All right, let's see here. I think this problem is going to be pretty much the same situation. So why don't you go ahead and try number 31, and when you come back, we'll do it together. All right, we're back. 32 minus 8 is going to be 24, and then 24 divided by 11 would just be 24 over 11. And then I'm going to square root both sides. And we're going to have to pull out the perfect square from the numerator. Again, this becomes root 24 over root 11. We learned that. That's the first step. Then you have to pull out the perfect square from 24, which I just did there. So I went from here, then down to here. And then you have to rationalize the denominator. So you have to do two things. You have to pull out the perfect square out of 24, then you have to rationalize the denominator. Multiply both sides by root 11, and you get plus or minus 2 root 66 over 11. And then y is equal to 1 plus or minus 2 root 66 over 11. And that is the answer. So if you got that answer, good job. If you didn't get that answer, just go back and figure out what you did wrong. Or you might have to go to the previous class and review some of that material. Just double checking that, everything looks right. Try number 32. And when you come back, we'll do it together. All right, we're back. Isolate the square by doing 2 steps at once. Square root both sides. And I'm just going to do all of that in one step. It's going to be root 21 over 14. Let me just double check that. That looks right. And then we just have to add 2 to both sides. And again, I can move the root 21 over 14 over to the left and then put plus 2 on the right. Or I can put the 2 over here. So if you got that answer, good job. I should probably put that plus or minus a little closer there. All right. So try number 33. Actually, let's see what's going on here. You know, let's try this one together. So subtract 4 from both sides, divide by 27, and you get 20 over 27. So we isolated the square. And the difference with this problem is when we square root, we're going to have a perfect square in both these numbers. So we're going to have to pull out a perfect square as a factor in both 20 and 27. So we have x plus 2 is equal to, and now again, we go to square root 27 over square root 27. And then we have to deal with those problems. So I'm going to show the steps on this one just again to jog your mind. I have not been showing the steps again. We did this in a previous class, but now I'm going to show the steps because we're doing a lot here. So pull out the perfect square in both these numbers. 20 is 4 times 5, so the 4 comes out as a 2 because it's a perfect square. 27 is 9 times 3, the 9 comes out as the 3 because it's a perfect square. Now you're probably thinking, well, some of you might be thinking if you didn't do the homework, well, why did 9 come out as a 3 and 4 came out as a 2? Well, if you're asking that question, then you didn't do the homework from the previous class. Square root 20 is square root 4 times 5. You can take out the 4. When you take out the 4, you have to square root it because we learned that square root 4 times 5 is equal to square root 4 times square root 5. This becomes 2. 2 square root 5. So again, if you're having trouble with that, that's a bad sign because that means you're not doing the homework. Sorry to harp on you if you didn't do the homework, but if you don't do the homework, you learn 0 in this course or any other math course. And you can't cheat. You can't get away from that. There's no way to learn this stuff without doing the homework. No one in the history of the world has ever learned any kind of math whatsoever without doing homework. Period. End of story. And you won't do it either. Trust me. All right, so we pulled out the perfect squares. And now we're going to multiply both sides by root 3. And we get 2 root 15. And that's it. That's the final answer. Alrighty, so why don't you try number 34. And when you come back, actually, you know what? Let's see here. Let me check something here. Actually, don't do number 34. I think I mixed up these problems. This one should be down here. Sorry about that. So now 34 is similar to the problem that we just did. So go ahead and try 34. When you come back, we'll do it together. All right, we're back. So we get 8 over 63 when we try to isolate the square. And then we square root both sides of the equation. And I put this too close to the equal sign as usual. Sorry to keep doing that. I don't want to waste your time. And then we get 2 plus z is equal to, and we have to pull out the perfect squares. So on the top, square root 8 is equal to 4 root 2. Whoops, that should be 2 root 2. And 63 is 9 times 7, so that would be 3 root 7. We pulled out the 9, and it became 3. Then we multiply both sides by root 7 to rationalize the denominator, and we get 2 root 14 over, and this just becomes a 7, so then you multiply it into 3, it becomes 21. And then the final answer, we just have to subtract 2 from both sides, and we get negative 2 plus or minus 2 root 14 over 21. I'm going to try to make a little more room here. So if you got that answer, good job. All right. Sorry, I'm just trying to make this neat. So let me just double check that real quick. 2 root 2 over 3 root 7. 21. Everything looks good. All right. So we're doing good. We're almost there. We got 6 more problems, it looks like. So let's do number 35 together. We're going to isolate the square, just like the previous problems. And we get 32. Subtract 8 from both sides, then multiply by 4, and you get 32. So now, as usual, we're going to get rid of the square by square rooting. And we end up with 3y plus 2 is equal to plus or minus root 32. But we can factor 32 to 4 times 8, but the problem is, even though 4 is a perfect square, 8 is a factor that contains a perfect square inside it as a factor, so we don't want to do it that way, because that would require 2 steps to pull out the perfect squares. Because we'd have to pull out 4 as a perfect square, we'd also have to pull out a 4 inside the 8 as a perfect square. So instead, we're going to factor this to 16 times 2, and that'll be a lot easier. Then we just pull the 16 out as a 4, and the 2 remains, and we pulled out all the perfect squares in one step. So so this is the part that's going to be different, because now, in order to get to the y, in order to isolate y, we have to actually do 2 things. We have to get rid of that 3, and we have to get rid of the 2. So that's why this problem is different. So we're going to subtract 2 from both sides. And I can put the negative 2 over here, or I can put it over here. It doesn't really matter. I'm just going to put it on the right. So I'm going to subtract 2 from both sides. And then I have to just divide both sides by 3. And please understand that when you divide both sides by 3, you have to divide this entire expression by 3. Not just 4 root 2 or 2. You have to divide everything by 3 to get rid of that 3. So that's the only difference with that problem, is that the last part of it required 2 steps. So try number 36, and when you come back, we'll do it together. All right, we're back. Isolate the square. That would give us 54, it looks like. And then we're going to square root both sides. We have to pull out the perfect square in 54. 54 is 9 times 6, so 9 comes out as a 3. Then we have to subtract 1 from both sides. You really don't have to show both steps here. I'm just showing the steps just so you see what's going on here. From here to the answer, you don't have to show both steps. You just have to show the result after performing both steps. All right, and then divide both sides by 2, and you get the final answer. So if you got this answer, good job. And hopefully you're rectangling all your answers. You got to rectangle those answers, or else your teacher's not going to know what your answer is. It's going to be hard. Well, she might know, he might know, but it's going to be difficult to find the answer among all the writing. All right, so on to the last 4 problems. Let's see here. So why don't you try number 37. Actually, let's just do this one together. So we're going to isolate the square. Again, the only reason these problems are different is because inside the square we have more complicated calculations. But it's the same situation. Just isolate the square. Looks like we get 3 over 5 when we do that. And then we're going to square root both sides as usual. You're probably sick of me sounding like a broken record at this point. But the downside of me sounding like a broken record, or the upside of me sounding like a broken record, is that you can't claim that you don't know how to do these problems, because I've told you 50 times. Actually 37 times to be exact. All right. So this, we have to do all the steps there, so that would become plus or minus root 15 over 5. And, ouch, this is going to be a little weird. This is not going to be pleasant for us, trust me. Well, I shouldn't scare you. We should just do it. It's not going to be that bad. So add 3 to both sides. Yeah, this is not going to be that bad. But this is going to be a source of confusion when you do the homework, so please be aware of this problem. I'll put a star by that. And it's going to be a source of confusion because of why? Because of this step that we're about to do. From here to the next step. I should get that out of the way there. All right. So now we have to get rid of this 2, right? We have to isolate the z, and we have to get rid of that 2. So we have to multiply both sides by 2 to get rid of the division. So here's the part that is really confusing for students. When you multiply both sides by 2, you're multiplying by a sum. We have plus or minus root 15 over 5 plus 3. So I'm going to need to show all these steps. I can tell this is going to be a source of confusion for students. So I'm going to make as much room as I can here. So I'm going to rewrite this. And I'm going to multiply both sides by 2. Now I don't usually show the steps, but in this case I think I probably should, because we haven't done this. I have to put the entire expression in parentheses here because I'm multiplying everything by 2. Now again, because I'm multiplying a sum by 2, I have to use the distribution rule. So the distribution rule says that when you multiply a sum, you just multiply each term in the sum. So 2 times root 15 over 5. If you multiply 2, I'm going to use a dot here just so you know what's going on. And maybe you should turn that. I'll just leave it in that color. So you're multiplying a fraction by a whole number, and whenever you do that, remember, you just put 2 over 1, and then you multiply the numerators and multiply the denominators. So 2 times root 15, we can't really do that. We just put them next to each other. Remember, when you're multiplying a root by a number, you just put them next to each other. And then 1 times 5 is 5. So 2 times this expression is equal to 2 root 15 over 5. That's it. No big deal. Then you have to multiply the 2 into the 3, and it becomes 6. And then we just isolated the z. We're done, because these 2's cancel out. That's why we did that. So hopefully you're going to understand how we got there. I could show the steps, but I don't really want to do that on paper. I explained the steps to you, so if you have to come back to this, you're going to have to listen to this explanation as opposed to looking at it on paper, because I'm not writing every single, I'm not writing that I'm multiplying by 3 in the fraction and so on and so forth. I explain it in words rather than explaining it on paper. Oh, I forgot my plus or minus. Don't forget that plus or minus, or your answer is going to be wrong. So that one was kind of a challenge problem. It wasn't kind of a challenge problem. It was actually definitely a challenge problem. Those are all concepts that you learned in a previous class, but now we're adding square roots and all kinds of weird stuff. So that was a good challenge problem. So why don't you try, let's see here. Yeah, why don't you try number 38? And when you come back, we'll do it together. All right, we're back. So isolate the square. And the square is equal to 30. And we just follow the same procedure, and I'm going to try to make as much room as I can here. And there is no perfect square in 30, because if I factor 30, it's 5 times 6. There's no perfect square. I can factor it to 2 times 15. No perfect square. I can factor it to 3 times 10. No perfect square. So we can't pull out a perfect square from 30. We just leave it as root 30. So this problem is a little easier because we don't have a fraction here. So I'm going to subtract 1 from both sides. And please understand that the difficulty with this problem most likely was that you may have not carried down that -1 to the x over 3. This negative goes with the x over 3. It does not have anything to do with this 1, other than it's connecting the 1 and the x over 3. So if you got this problem wrong, that's probably the source of error. So now what we're going to do is we're going to do something tricky. We're going to bring that negative down to here, and it's going to be much easier. Whoops, it's going to be much easier to deal with. So now we know that the last step is to get rid of that negative 3. X is divided by negative 3, so the opposite of division is multiplication. So we're going to have to multiply both sides by negative 3. So I'm going to go ahead and rewrite. Again, normally we don't show the steps performed on both sides of the equation, but in this case I think it's necessary because there's a lot going on here. So I'm multiplying both sides by negative 3. I obviously need to make room for myself here. In fact, I'm going to move this entire equation over. I have to put the entire thing in parentheses. All of this in parentheses. Because I'm multiplying both sides of the equation. This is one entire side. I have to multiply everything by negative 3. So then the negative 3's cancel out, which is why we did that. Now we have x isolated. We just have to simplify this expression. So we have to use the distributive rule. Negative 3 times plus or minus root 30. That's just going to be plus or minus root 30 times 3. So you just put the 3 right next to the root 30. And I just realized that that's something that I did not explain. I should have explained that to you before I gave you this problem. That's my fault. We have a plus or minus. We're multiplying by a negative 3. So what does that mean? Well, this can be positive or negative. So if you multiply it by a negative, it still just means it can be plus or minus. So you just keep your positive or your plus or minus. I know that sounds kind of confusing, but just understand that if you take something that can be either positive or negative and you multiply it by a negative number like negative 1, then it just ends up being the same number. Well, let me give you another example. Let's say you multiply by negative 2. Then you would get 6, right? But if this were positive 3, negative 2 times positive 3 would be negative 6. And if this were negative 3, negative 2 times negative 3 would be positive 6. So I think I said that right. You get negative or a positive. So it doesn't matter if this number is negative or positive. It's not going to change the positive or negative sign, the plus or minus. If you didn't understand that, no big deal. Just remember that if you multiply any number by a plus or minus, the sign just goes away and you just keep your plus or minus. I know that's kind of confusing, but no big deal. Just remember how to do it. And you can go back and figure it out when you have time later on, or years from now, or whenever you want to go back and figure that out. Negative 3 times plus or minus root 30, we got that. And now negative 3 times negative 1 is positive 3. So that is the answer. So I'm sorry I didn't tell you about that last part there. Again, these problems have so many variations, it's hard to predict every single variation for every problem. All right, so let's just double check that. Everything looks right. So if you got that answer, good job. We just have 2 more problems. So those last ones, I'm going to put a star by that because when we multiplied by negative 3, we had to do some crazy stuff there. Crazy logic. That's kind of an oxymoron, crazy logic. All right, so let me look at 39 to see what's going on with this problem. I think you can probably attempt this problem. So try 39, and when you come back, we'll do it together. All right, we're back. So we're going to add 8 to both sides and divide by 7. We get 2/7 equals y over 4 plus 2 squared. Square root both sides. And we get y over 4 plus 2 is equal to root 14 over 7. And then we subtract 2 from both sides. And again, you can put the negative 2 over here, or you can put it over here. It doesn't really matter. And keep in mind that plus or minus, it always goes with that root 14 over 7. Let's see, what do we have here? So y over 4. And then we're going to multiply both sides by 4. And this is the part that I'm going to go ahead and rewrite. Again, you don't have to show the step, but I'm just going to show it because things are getting kind of complicated with these problems. So we're going to multiply both sides by 2, and I'm going to go ahead and put that in red. Excuse me, multiply both sides by 4. And we get y is equal to plus or minus 4 root 14 over 7 minus 8. Again, we use the distributive rule. We distributed the 4 and multiplied it into both those terms in the parentheses. And that's it. That's our answer. So if you got that answer, good job. This is complicated stuff. Very complicated stuff. So it's going to take a lot of practice. Now, I assume that my problems are going to be somewhat more difficult than the problems you're going to do in your textbook. So that's good news. But you do need to know how to do the complicated problems in my class. All right, on to number 40. So go ahead and try number 40, and when you come back, we'll do it together. This is the last problem. All right, we're back. So I think we get 40 is equal to the square. And then we're going to square root both sides. And we're going to have to pull out the perfect square here because there's a perfect square factor. So 40 is 4 times 10. 4 comes out as a 2. And then I'm going to have to subtract 3 from both sides. I can put it on the left or the right. It doesn't really matter. And then I'm going to multiply both sides by 8, and this is the part that I'm going to show, because I don't want there to be any confusion about the distributive rule that I'm using. So I'm rewriting the problem to preserve the result of the previous step, and now I'm going to multiply, get my red pen out. I have to multiply everything by 8 on the left side of the equation. And I'm going to see if I can save some room here. Our final answer is going to be negative 24 plus or minus 16 root 10. So we learned how to multiply expressions. You know, if you're complaining that you don't know how to multiply 8 times 2 root 10, that's probably because you didn't do the previous class. We learned how to do that in the previous class. Again, if you do your homework, you should know how to do these problems. And if for some bizarre reason your homework didn't have a problem like that, well then just go to my previous class. I give you tons of those types of problems. So if you got that answer, good job. So that was the class today. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. Don't go before you get your homework. Here's the homework. Get a screenshot of these first 2 pages. And a screenshot of the last page. Be sure to get that homework done completely, correctly, neatly, and keep it in order in your binder. And I'll look forward to seeing you in the next class.